Okay, let's start. Just a few things about us. The slide is a bit bored because of the resolution. We work in a company, a local company in Toulouse, and we work in software factory and that kind of thing, automating things, and on and on. What we are going to talk about today. So don't worry, this is actually a lab, so there will be only slides to be able to kind of have another look another view of the basics of Git to settle down things quite correctly, and then we will try and manipulate things a bit more. So we are basically going to speak about the history of Git. Then the data model, understanding how it works. We will practice about things like rebase -i, interactive rebase, and then we will try and dig in some of the coolest things of Git. Okay, some fun and quite in short introduction about the Git history. Git started about 10 years ago, and funnily, I don't know if you read correctly English, but Torvalds actually said a long time ago that .tar was actually far superior than CVS. I hope nobody here still uses CVS. Okay. If not, you're pretty unlucky. And then for 3 years, the Linux kernel used a DVCS, which is actually still called BitKeeper, and this stopped because one of the members of the kernel tried to reverse engineer it. So April 2005, the first, and 7 April of 2005, Git was born. 1 week. I don't know if you read it. In English, Git is someone pretentious, I would say. Yeah. Which is not really cool to work with, I would say. DVCS, what is it? DVCS is decentralized, obviously. And technically, you don't need any server. I don't know, for many people it's not that obvious because you actually use in general to have a company where you have a central place where every developers push their code. So that's not something actually a lot of people practice, but you have to know that there is no technical requirement to have only one server. One place, I would say, because there are no real concept of a server with Git. A small part about why Git is actually quite performant. It boils down to where it comes from. It's because the Linux kernel and the way how the Linux kernel works needed to be pretty quick to process a lot of things. So that's why mainly Git is quick, and Git generally does the merges quite correctly. It's also content-oriented, and that's a big difference between, for example, Git and Subversion or CVS. I think it's the same. It's content-oriented versus Delta storage. Delta storage is the thing where you want to store inside the VCS, the versioning control system, only the difference, the delta between commits. With Git, actually everything gets every time stored and actually compressed afterwards. A very, very important concept in Git, which actually doesn't exist in CVS version, and I'm almost sure it doesn't exist in other DVCS. You have a place where you can craft your commits. This is actually very important, and most of the time people who just started using Git didn't really get what the usefulness of that is. And so some interesting command mainly relating to that staging area, which is also called the index. Anyway, the fact that you can craft your commit correctly and prepare the next commit you're going to do. So a little quiz about that. Who thinks there is a question here? You see echo the first one with the 1 here and the 2 here. So you've got a content here, blah, and another content here. So who thinks what's going to be committed? So who thinks it's the content listed on the line numbered 1? And who thinks it's the number 2? Nobody? Who don't have an opinion? Well, anyway, it's indeed the first one. And why? It's because actually when we say Git is content-oriented, Git actually adds the content of the file you're adding when you do git add. The content, not the reference to the file you're adding, like in SVN. Because actually, with SVN, it's indeed the second one. That's very, very important to understand. Okay, let's try and dig a bit deeper now. As the law of John Gall says, a lot of things that work are actually, I will try and reformulate it, but the complex things that works are invariably found to have evolved from simple things. And actually, Git is pretty simple at the basis. Git, how would you do if you wanted to design a versioning control system? At the basis of that, you have a file content, I would say. And it's indeed important to understand. It's only the file content, not where it's located and so on. Only blob, like in a database, classical database. Then, how would you represent where that file is located? You have the concept of a tree, which is actually a typical directory. And a directory points onto directories or blobs. Indeed, files. And then, to be able to wrap up that versioning control system, what do you need more? You need something to reference that tree. And this is a commit. And a commit actually references a root tree, which is your project, your repository, and can reference 0 to n commits, parent commits. And Git, if I remember correctly, is one of the only, or maybe the only one DVCS to be able to have more than 2 parent commits. I think that's quite obvious for most of you, but a SHA-1 is 40 characters hexadecimals wide, and you can use actually minimum 4 characters to reference a commit, and you will be able to use it if this is not ambiguous. And another one, a last one, which is actually not really necessary from a design point of view, and more to be analogous to be compared to the DNS system, for example. In the DNS system, you know the server names are only useful for humans, but the machines don't care. The first thing machines do when they want to use, when you want to reach a remote server, they will first resolve it. That's actually the same thing with Git in general. General will only work with SHA-1, SHA-1. And the tags is only a human way to be able to remember, for example, is because it's like actually, you will agree that it's easier to remember 1.0 than 40 characters long text. Some wrap up, and I think we will have to continue then. So, summary of what I just said. A commit can reference a commit, and a commit points to a tree, which is actually a root tree. And a tree is composed of trees, like your file system, actually. You see it. And then you're done. You understood how Git stores your data. Okay, back to basics. So I'm going to now give the mic to Mike. Sorry for the lag.
So I will begin by presenting you my apologies because I'm not as fluent as Baptiste is, so sorry, but it's a work in progress. So we start with a quiz. So what does this? In the first line, we create a new Git repository. And then we add a commit, an empty commit on it. And then we create a .git ref heads path file with content ABC. So what does this in idea? Go.
A branch?
Yes. That's right. It creates a branch. Of course, the content of the path file ABC is not a valid SHA-1 for a commit. So if you git check out that branch, Git will raise an error because the SHA-1 does not exist. So what are branches again? A branch with Git is just simply a pointer to SHA-1 of a commit. It's kind of symbolic link. Git only references heads in terms of a branch can only reference a head commit of a commit tree. A commit can be in a dangling mode, dangling state, excuse me. If, for example, you make a rebase, we'll talk about rebase more later. And if that rebase is without fast forward. So Git has a garbage collector, and if the commit is in state dangling, it will be garbage collected. So what are pointers? You have head keyword. Head keyword is referencing the latest commit of the current branch. You have a shorthand head tilde. For example, 3, head till 3, reference the third commit before the current one. If you omit the number, it references the head till 1, it's the same. If you're located actually in a branch and you had a commit, the current branch is automatically bumped with the SHA-1 of the new commit. Resetting. Baptiste has explained a little the principle of index. Git reset permits to reset the state of a working directory to specific SHA-1. And we have three modes with reset: soft and mixed and hard. Soft and mixed keep local changes on working directory always, but the difference between those two modes is that soft will keep changes in staging area, and mixed will only keep changes on working directory. And the third is hard. Hard is just the more simple. Discard all changes in all abstract level, donc working directory, staging area, and repository. a little example, git reset head tilde. This command will use the mixed mode because it's the default one. And in this case, it will keep the working directory intact, donc any change in the working directory, but it will remove the current commits in the repository. So if you execute git log, the commit will not be shown in the git log command. Another example with hard mode. In this case, git reset head hard head tilde 2. It will just set the working directory to the state of the head tilde 2 commit. And any uncommitted changes will be discarded. We'll talk about merge or rebase. That's a good question. What is it and how to choose one or another? The first important question to ask when to choose one or another is what do we want to do? Because if you step back and what do you want to actually do, Git lets you express what you did. But the real sentence for this is Git is more powerful than that, and Git lets you express what you wanted to do. So, like a good code reveal intentions, Git lets you express and reveal what you wanted to do in the commit history. So, when to use rebase or merge, rebase is to rebase is to when you want to have a linear commit history and don't want to show a sub-work of your work. Merge is to use when you want to express in the commit history that you have a parallel work, sub-work in the commit history. Now we'll explain more rebase. So we have some commits. We have two branches, branch feature, branch master. We are currently on the feature branch feature, and we want to rebase the branch master. So how rebase works? It will rewind commits of the branch feature. Oh, excuse me.
You rewind too.
You rewind commit from the feature branch up to the first common commits of the two branches. So it will move to the latest commit of the branch master and replay all commits of the feature branch. So that's a rebase. And if you see the commit history, it's just linear. Okay, it's not sub-work like a rebase, like a merge can do. So now for the same example with a merge. Donc you are currently on the master branch, and we want to merge branch feature. Git by default will create merge commit, and the resulting working directory is the same as the rebase, the previous rebase example. So, but the commit history is completely different because we see that the work has been merged by a commit merge commit. Now, by default, but if it can, Git will not create a merge commit because if it can fast forward is just bumping the branch pointer to the latest commit of the branch we want to merge. Cool. And you have if you want to prevent that default behavior, we have the --no-ff option to to create a commit merge in any case. So an example, for resume, rebase is to make a linear history, and merge is to have express a subwork history. So, but in the case of a fast forward, if there is any conflict, if there is no conflict files for two branches, merge and rebase can do the same thing, exactly the same thing.
Okay, we are almost done with the presentation. Don't worry, we are going to practice in a few minutes. So just some tips and tricks, and we are going to practice some. So I hope, and now you will know it. There are some command like git reflog that can save your work to be able to revert the things you did. So use it really often. Maybe, for example, if you do a rebase dash I and that kind of things, you can always revert to the previous version of your history. We are going to practice on that one. So what if you know the 1.0 version was working and you worked a lot since that commit, and you did maybe 100 or 1,000 commits between those two commits, and you don't know where you introduced that stupid regression? There's a standard command with Git, which is called bisect, which will let you binary search the commit which introduced the regression. You can use it manually or even script the finding of that offending commit. Some a bit lower level things before we manipulate about repository lifecycle, because this is actually a question often asked from, for example, people coming from Subversion, where you can actually store dung in your directory, your version directory, because I would actually say that Subversion is not really a software project versioning control system, but more something like a remote directory versioning system. So in Git, you can't store different projects. You shouldn't store different projects who have different life cycles. So mainly the answer is, if you release projects together, they should be in the same repository. If you release them separately because they have a different life cycle, then there should be two different repositories. Sorry. And you can even choose afterwards if you want to aggregate. It's also possible. It's just a typical merge, an almost typical merge. And we are going to practice on that one, but you can even afterwards split repositories even after you merge them, or if you started working like this way. Some words about EGit and JGit. EGit is the Git plugin for Eclipse. It's actually now working pretty fine. It's been quite unstable many months and many years ago, and now it's a bit better. And JGit, which actually we use, is quite cool because you can, in Java, manipulate a Git repository. So a small capture of the place where I actually use most often EGit, because I most often use Eclipse and EGit for staging selectively things out. You generally should take the habit to never stage the whole files in one way. You should try and select the things in the files you want to craft your commits, and maybe you can prepare, we will see that, prepare commits even from the same file, which will actually make two different commits. JGit, some examples to show that the Fluent API is quite straightforward. This is a clone, this is a fetch, and enough talk. Let's start. So everybody, you should have now retrieved the material. And you should open that file, which is called alllabs.html. Open it, and if anybody didn't retrieve the material yet, just ask. We have some USB keys going around. So I'll just present you with that lab to help yourself getting started. So what we're going to do here, we are going to actually try and play with the things I said some minutes ago about the data model. You're going to try and dig in the data model and understand how Git works. So it should be quite straightforward. We try to be quite driving, try to be clear about where to go. If you have any question, we are going to go through the room and try and help you. And we have about 10 minutes. I think we will finish in 10 minutes. 11 and let's say 5:55. 11:55 maximum for the correction. Let's start. Okay. Your attention, please. We are going to present the second lab. I think most of you should have tried and play with the first one, but we want you to go to the next one because we really think the second lab is the one you should spend time into. So I'm going to present you with the second one so that you can do it. The second lab is about I would say the killer feature of Git, which is about rewriting. If you don't rewrite in general with Git, you don't really use Git yet. Because this is something you should be used to do many times a day. For example, most of the time, I almost never push without rewriting the things I have locally. So what are we going to do here to just get you started? You should now switch with the change directory, cd just, typical, to the Git repository we provided in the lab materials, which is called Git's Next Level Rewriting. cd to that directory and get started. You have a few steps, and actually we are going to make you rewrite the history of that repository. So we will start quite easily with just rewarding the commit log, and then it will get a bit more hairy with commit splitting, commit reordering, and that kind of things. And if you have any questions, obviously, we are going to go around and just ask us. Let's start. Just an interesting question and an adjustment, I would say. You should be aware that Git is actually quite well known for his weird comments sometimes, and you should, in your mind, separate rebase and rebase-i, because actually I would say that rebasing interactively is not really, at first sight, close to a rebase. So I had some questions about the difference between rebase and rebase-i. I would say that you can split them totally store them in your mind as kind of different commands, even if the rebase part seems to be common. Okay, I'm gonna do now the correction for this lab. So, yep, if I find, just try and finding the right directory. Okay, what we want to do, I think it's readable. What we wanted to do was to actually take those commits, the last one, the previous one, and the previous one, and merge them into a consistent commit and only one, because Git is also about, as we said, expressing a good history and not just dumping garbage into the repository. So how do we do that? It's quite simple, actually. I have to point onto the commit I want to rebase. And I can also just do, if I know the value, if I know that this is the last three ones I want to rebase, I can just do something like git rebase -i head tilde 3. And this is gonna open the editor on what I want to do. So what I want to do here is actually to reward the first line, because I want to remove the part 1, part 2, and so on, because it's not going to make sense anymore. And just wipe out, merge the following commits with fixup. How do I know which command I can use? You just have to read what's displayed here. Okay? So if I do that, actually, Git is going to take the commit in the order displayed here and apply what I required. It's going to be quick, so I'll explain it just now. It will reopen the editor on the first commit to let me rewrite it, reward it, and then it will just wipe out the next commits and take the content and put it inside the previous one. So let's just do it. Quit. It was quick. So the VI is reopened. Okay, let's just remove until the end. And there's quit again. And now we're going to see around the bottom that it will be quick again, but it's going to rebase the second one and the third one. Okay. So now if I have a look at the history, you can see that there's only one commit with the content of the commit we wanted to rewrite, rework. Okay, next step. The step we wanted you to spend time into, mostly because this is actually the one that if you were able to do it fluently, you will be fluent in almost anything in Git. So what do we want to do here? Here, again, you can see two garbage commits. Here you can see that the commit modified the footer and the header in the same commit. And then there was something like a fixed commit just for the footer. What we are going to do is to try and clarify it, and split that commit into two commits. And then when we will do a commit for the header specifically and the footer one, we will just merge the footer one with the previous one, with the next one, which is about the footer too, to have only then, when we will have done the rework, we will have two clear commits, one about the header and one about the footer. Okay, let's just do it. So again, what I want to do is to point onto the commit before the first one I want to play with, I would say. So how do I do that? I just copied the one I'm interested in. So git rebase -i that commit, and VI is going to reopen once again. So what do I want to do? What I want to do is editing that one, and when I will have edited it, I will be interested in squashing the next one, because I'm going to split the first one into two commits, and then I will want to take that commit and squash it into the commit I'm going to create. Okay? I hope I'm being clear about what I want to do. Just quit. And okay, I'm stopped. Where did I stop? You can see that if I do git log, I have been put during a rebase, an interactive rebase. That's where the link you can find between the rebase and an interactive rebase. I'm going to now split those commits. How do I do that? The simplest way is to use the thing we talked about some minutes ago about going back into the history, wiping out the commit we want to wipe out, but not the content. So how do I do that? Remember, I'm just going to do a reset and go back one commit to wipe out the current commit without touching the working directory. Okay? And now you can see that I am in a state where the current content is indeed modified. Now what I'm going to do, le footer c'est après. Oui. Donc what I'm going to do is stage first commit with the header and another one with the footer. So how do I do that? I'm going to use a command which I actually don't use pretty often because I prefer using a GUI editor for doing that kind of thing, but I'm going to do that for the exercise. I'm going to stage by hunk, it's how it's called with Git, by parts, the file, the index file to stage only the header part. So how do I do that? Hit add.p. You can see that here it's proposing too many things at once. So I'm going to ask Git to just stage the first part. So I'm using the S, which is meant to mean split. And now it's just going to reopen with the first part. Okay, and now it's indeed asking me if I want to stage the header part. So I'm going to say yes. And then it's asking me if I want to stage the bottom part, the footer part, I would say. And then I'm going to say no, because I don't want to stage that part for now. If I do a git status, you will see that the file is now present both in the changes to be committed and in the things that won't be committed. That's logical because we staged only some part of the file, which is one of the killer features of Git, to be able to stage selectively files. So now I'm going to create a new commit without opening VI with -m, the header, which was the header part. Okay? Okay, no alias. Okay, sorry, I was trying to use an alias. Okay, I did a commit with the header part. I'm almost done. If I try and see now the modifications left inside my working directory, you can see that there are still some things to be committed. Let's just have a look at what is inside those modifications. You can see that there is indeed only the footer left. So I'm going to create a new commit with only the footer left. So I'm now going to add the file directly. You could also stage selectively with add-p as we just did, or using a GUI. But as we know with just used git diff, you know there is only one modification. I'm going to stage the whole file in one go. And now just do another commit specifically for the footer path. Done. And if I do git status, you can see that there is nothing left. And as I just said to some of you, you can see that Git is indeed displaying some documentation, inlaid documentation for what I want to do next. And you can abort the interactive rebase you're doing, or you can continue. This is what I want to do indeed, because if you followed, you know that we went back we kind of do some surgery. We remove the commit. We did some new commits, and we are going now to replay what we put aside above what we above the new things we just did. Git rebase -- continue, and if you remember what I put inside the file some minutes ago, I put squash. So what is going to happen now is that the editor is going to come up once more and to let me merge the previous commit log I had for the footer part with the current commit, last current commit, which was the footer part I wrote. You're going to see it. So you can see here already Git is showing me two different commits merged into one and lets me rewrite, reward the commit log. And so I'm not going to keep that one. I only did it to be able to just be more progressive for the audience. But I don't want actually to keep that one. I could have used fixup. OK, I'm done. And I'm going to quit. And now Git is going to take the next commit we put aside and rebase until we replay every commit until the last one we initially already rebased. And if I do git log, you can see that now we have at Jumbotron, the first one we rebased, and I have two clean commits here, one about footer part and one about the header part. And I won't do it now because we want you to play with some other things. But you could also, for example, merge that one with that one. That would be pretty easy compared to what we just did. OK? Right. OK, now I'm going to introduce you with the last nominal lab we want you to play with, which is about using bisect. So you just have to switch using CD to one of the other Git repository we provided you with, which is called, as written in the documentation, Git next level workshop bisect.git, or without the .git part, I guess. What do you have to do? In that repository, there is an index.html file, which is which is buggy. We introduced a bug some months ago. You can see here that there is indeed a very, very bad bug. And if I show you the history of that repository, you can see that there is, I'm typing on the space, so you can see that there is quite a few commits. And we tell you that that commit was OK. So there's 600 commits between those commits. So what we want you to do is to find the offending commit between those 600 commits. Pretty easy. Let's go. OK, I will introduce you with the bisect command. How to check that commit is indeed working. I'm just trying to define the border here, the borders here, trying to find where it began not working, or where I know it's not working, and where I know it was working. So if I show you now the page, you will see that I didn't check out. Yeah, entrée. Yeah, that's the point. No alias. Michael doesn't like aliases. OK, and if I refresh, you can see that everything was OK. OK? So I know now that that commit was OK, and I know that master, or current head branch, is not. So I go back, and then I'm going to start using bisect. So I'm going to start using bisect. That's what you're going to do, and I will let you do it. And then you are going to put milestones, I would say, where it was OK and where it was not OK. For example, I know that it was good here. And I know it's not bad, it's not good, it's bad. On master. And now, I always find that command quite a bit funny, because Git is doing some chess here. I think I can do it in roughly 8 steps. So let's just play it. And now what you're going just to do, and when you are here, you are going, Git is going to set you on different commits, and you are just going to have to answer if the current commit is good or not. And for example, to just get you started, here, if I try to have a look, I see that Ouais, comme ça c'est bon. Ouais, bon, je laisse faire après. That one is bad. Okay? On laisse faire un peu. I think, I'm not sure, we're not running out of time. Non, mais c'est peut-être bon, c'est jusqu'à 13h au final, on a 10 minutes après. Ouais. Ça va être un peu just. Okay, I'm going to finish the thing. I hope you will be able to practice it offline, but I think I'm going to just finish it. Après, on va la conclusion. Hein. Là, c'est OK. I'm mixing French and English. Good. Good. Bad. There's a famous movie in France about bad. Pas bien. Alors, everything is okay. Is it still okay? Everything is okay, donc good. Bad. And you can see that indeed, the steps are going down. Here, that one is bad. And roughly 0 steps. You may wonder why Git is saying roughly. Actually, that's quite simple. He's doing a binary search. So, he's dividing the number of commits into 2 parts and setting you in the middle and asking you if it's okay. And then going on the left or on the right. You can represent a tree in your mind. So why roughly? Because if you have, for example, 11 commits, you will have 5 on the left and 6 on the right. And depending on what you answer, you will have more or less steps. Is that one correct? Yeah. Okay, we found one. So you can see that with the help of bisect, we found quite easily, with less than 10 steps, among 600 commits, the commit that introduced a regression. What we didn't show you, but which is quite easy to do too, is that actually git bisect, as you might have seen it, have a pretty several commands, and one is actually run. And run is designed to take a script as parameter, which should answer 0 or 1, depending on the commit is good, the current commit I'm on is good or is bad. So you can even script the bisection. How do you do it? For example, if you practice Java, you may imagine an issue with that. The typical case would be, indeed, if you had a regression you didn't see, that certainly means you didn't have the test associated to that regression. So if you run a script, and that script or that test case is a JUnit test, indeed, it's not in the repository tree. It's not in the commits. It's not in the old commits. So with what we learned today, you now would be able to write a new commit with the new test, showing the regression, making a temporary branch, taking that commit with the new test, showing the regression, putting it in the past, 600 commit past, by just moving it, and then using git bisect run to execute, for example, mvn test for those who use Maven here. Or Gradle test, it's exactly the same thing. This way, even if the tests are long, you are just going to go taking a coffee, and maybe an hour after, you will have the answer. We will have found the commit which introduced the regression, even if it's maybe 1,000 commits. And if you do some easy mathematics, you can see that indeed, as it's exponential, 2 power 8 is 256 commits. But if you multiply by 2, it's 512, and so on. So with 10 steps, with only 10 steps, you are able to process 1,000 commits. So you see the power here. With 16 steps, it's the 16 bits width, which is 65,000 and I'm difficult in English, and 536 possible commits with just 16 steps. We will finish on it. You may, I guess you already realized that using like Subversion, Git can be pretty simple. You can do commit, you can do pushes, you can do just retrieve data using fetch or pull. What I just said, and Michael said that too today, is also that when you're using Git, read the output. Rebase -- continue and that kind of commands, you almost often have actually the inline documentation when you're using the commands. So use it and read it. It's pretty useful. One useful thing when you're practicing Git is to know where you're in the graph. Because you should always know where, for example, I know I am currently on the tip of the master branch. Or I know that I started rebasing, so I'm maybe 3 commits down, and I know I'm during a rebase. Because that will help you know what you want to do next. If you know you're on master and you know there's a feature branch here that you want to merge, or you want to rebase on, you will do the commands accordingly. I hope today that quote will have been implemented. So just in general, practice a lot, and I think you will find that what we showed today was not that complex. Thank you, and if you have any question, we are all ears.